Hello and welcome to the 12th webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator here at 12D Solutions. Our 12D training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D model software. The aim of these webinars is to upskill 12D model users and broaden their understanding of the capabilities of 12D model. We'll keep running these webinars regularly and recording them for posting through our website and on YouTube. The first 11 webinars from this training series, as well as the first 17 webinars from our Industry Solutions series, are available online if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of the questions to the presenter for his insights if there's time. Today's webinar on traverse adjustments and least squares will be presented by Paul Hardwick, who has been in the civil construction industry for 16 years. He's worked as a construction surveyor on small and large-scale projects and has had many years of experience contracting to local authorities, carrying out detail surveys for pre-design works. Paul has been with 12D Solutions for over 4 years in a training and support role. Control networks are an important part of cadastral surveys, detail surveys, and engineering surveys. 12D has a variety of ways of maintaining a quality control network through the survey module. In this webinar, Paul will be discussing traverse and least squares network adjustments. Over to you, Paul.
Thanks, Lisa. As Lisa said, today we'll be discussing traverse adjustments and least squares adjustment as well. As usual, our job is not to tell you how to do your job, but to show you the tools that you can use inside 12D to achieve what you want and what you need. The first adjustment I want to show you is an adjustment of a boundary that has been surveyed. And if we have a quick look at this, I just use my string inquirer. I've got this boundary here. The overall length of it, about in the middle of the panel, is 2,577 metres, and the segment length there is right down the bottom, 567 metres, 0.027. So it's quite a substantial block that we're adjusting here, and our start of our traverse is down in the bottom corner here, between 1 and 10, so we run around clockwise, and it ends here on 10. So to measure this misclose that we have here, I'm just going to use my Control B, another shortcut key, or under Utilities, Measure, Bearing and Distance. So I'm just going to measure the bearing and distance between here, and I've got 127 millimeters in here, and here's my misclose in my bearing here as well. Okay, so that's what we want to adjust out of this. Okay, so to adjust this out, we're going to go to Survey, Adjustments, Traverse Adjustment New. So to start with, we're going to be using the loop method, which means it comes back and it's going to be closing on this coordinate down here at the end, so I don't get a choice of my closing coordinate. If I use the angular adjustment as none, that's the distribution of the adjustment. 12D will adjust the distances and the angles to achieve the method that you choose down here. So if I put in a tolerance here, before I do that, I'll just show you the coordinate adjustment methods. So you have transit, bowditch, compass, and least squares. In this demonstration, I'll be using bowditch. And here I can put a tolerance ratio that I'm happy to achieve. So I'm going to use 1 to 10,000. This will be up to you to decide what your authority or your organisation is willing to adhere to. Now I also get an option here for elevation adjustment, which I won't be using in this demonstration due to the fact that it's only a boundary. Okay, so if I just hit my pick and accept. It brings up the bearing misclose and the distance, and then it says the misclose ratio here is 1 to 20,000, and that's okay. So it meets our tolerances that we've set. If I go to my output tab, I can create a new model, or if I untick this one, I can overwrite this string and put a new string in its place. But I want to see what I'm doing as I'm testing out a few things here. So I'm just going to put a model in here called BDY adjusted, and I'll make it a different color so it stands out, and I'll give it a report file, which I'll just copy that down into there. So if I hit adjust, it brings up my report file. It's a nice 12D ASCII art. Then I have my original data with the bearings and distances between all of the marks here. Then I have my bearing misclose, my traverse length, and my accuracy. Then it will show me my final adjusted data and my new bearings and new distances that I have there. You can see here the distances have been changed. This one's by about 9 millimeters in the distance here. So this one has adjusted the distances as well as the bearings. So that's when I use the method here for none. Now if I turn that string on, so BDY adjusted, I can then come in and do some measurements between the old string and the new string and just see if I'm happy with what I've done there. Okay, so I'll show you a couple of other methods here now. So before I do that, I'm just going to clean out this model. Clean, and it cleans out that model. Okay, so if I come back to here, this time I'm going to look at using the weighted method. So the weighted method is what it sounds like. The shorter segments will get more angle adjustment distributed to them than the longer ones. And the linear will just count how many segments there are and divide the angular misclose by the number of segments and apply the misclose that way. So that's once again up to you to decide the method you want to use. I'm just going to use weighted here. So the terminology 12D is using here for closing azimuth is the calculated bearing that I want to achieve. So for me, this is this bearing along here, so from point 1 to point 2. So to measure what that bearing is, I can click on my icon, hover out on point to point, and choose bearing. And I can just pick anywhere on that segment and measure the bearing along that segment. So the closing bearing is the observed of what I measured from this last point here at 10 back to number 2 here. So we do the same thing. Click on this icon, point to point, and use bearing. Now because my points have point IDs, I can just type in the point ID and hit my space bar and it brings up the XYZ box. I type in 10, enter, and it will highlight point ID 10, and I can hit enter to accept. Now I can just measure over to 2, so I can type in 2, enter, enter. And there's my angular misclose. You can see roughly what it is there, about 30 seconds. 30 something, yep, 31 seconds. Okay, so once again I'm going to leave my method here as bowditch, and my tolerance, I'll leave that all the same settings. I just re-pick my string and see what it says here. So now it just gives me this bearing and distance misclose, and then I can hit my adjust. Replace my report, and I can have a look at my report. So this time I can see my closing azimuth here and my closing angle. My closing azimuth and my closing bearing, and then my angular misclose and the number of stations. Now when you use the linear method, it will tell you the distributed amount per segment just in here. So with lack of time, I won't go through showing you that, but you'll see the difference in the reports when you have a look at that. So that's completely up to you on how you use those tools. So what I recommend is you just do some experiments with the different methods. If you want to activate the least squares method down here, you'll just choose least squares, and then you can fill out these in here as well. Okay, so I'll go through, might have to go another time go through all these different settings in here as well, okay? So this is if you want to use the least squares method in here. Okay, so that's the loop method of adjusting your traverse. And if I come down here now, I can have a loop, and it's adjusted my traverse onto that point there. That will also work on a loop method if the string is closed or open the way that I have it here as well. The loop method will work for both. Okay, so I'll just finish that. And then we'll go now have a look at the non-loop method. So what I have here is a start point and an end point of my traverse. And maybe these were GPS or something like that. These are my two fixed marks. And I've got some booked measurements in here of my traverse. So to enter those in, there's many ways to enter the traverse in there, but I just want to show you one of my favorites. It's just under survey, extra, and then bearing and distance entry. Okay, the thing I like about this is it gives me a table here so I can see all of the bearing and distances as I type them in and correct them if I make a mistake. So I just type in a code, SBBM, which is my code for bent survey marks, and then it will fill out the model name and color, line style. This also allows you to put a scale factor in here as well, which is quite handy if you are working on a plan that is in chains. I can type in L after that one and hit enter, and then it will put in the scale factor to convert links to meters. So every distance that I type in here will automatically get converted by the scale factor. So it's really nice and handy. Now for my one, I'll just put it back to 1. For the point numbers, I'm going to type my point numbers, but there is also the option for auto increment and none there as well. You've got your start point coordinates in here. Now I'm just going to start on point 901. And I'm going to put in a different point ID just so I can put in the difference in there. And so I'll put in there 901A. And I want to use Z values. That will enable me to have this column here. So I'm going to type in on my other screen, I've got what I'm typing in here, so I'm just going to type in 902. And my bearing is 96.2906. Okay, so this bearing is in HP notation. So it's 96 degrees, 29 minutes, and 6 seconds. Okay, so there's no need for decimal points or anything like that. If you've not used 12D much before, you can, but you'll now understand how that works. Okay, so then I'll put in my distance, 286.709, and my height of 174.519. Now, so that you don't have to see me type all this in, I've got it in Excel, but you can see here as you type in, it just starts to appear on the screen. So if I just put in enough lines in here now, and I should be able to go on to Excel. And paste that into there and hit process. And you can see my traverse appear there. So that's saved a little bit of time. You don't have to watch me do all that typing. Now if I have a look in here at the end of my string, you can see my misclose here. And once again, to get the bearing and distance between the end of my string and my actual point, I can use my Control B, and to get up my measure bearing and distance, or utilities, measure bearing and distance. Okay, so I have about 13 millimeters that I want to adjust out of this traverse. The other real nice thing I like about this is if I've missed a leg in my traverse, I can highlight that row and insert above and just put in the missing leg, and then it will adjust the traverse accordingly. So I'll just put one in here. Let's go 50 for 200 and I highlight 100 process. So then you'll kink it out like that. So really, really handy. And just delete it. I just right click on that, delete, and process to put it back. Great tool. Alright, so I just finished that. And now I just open up my same option again. So survey, adjustments, and traverse adjustment new. This time I'll be using non-loop. And I pick my closing point coordinate, which will be 904, enter, enter. Okay, so same thing here. If I don't want to distribute my measurements, if I just leave it as none, I can just put in my tolerance here of 10,000 and pick and adjust. Okay, so I'm ready to go. But this time I do want to do my weighted method again. Why not for this one? Because they're all very similar type lengths, I'll show you the linear one while we've got time here. So same method here. Now this time I need my closing azimuth is going to be between my original control point 904 and 901. So my closing azimuth, click onto that, point to point bearing, and I can just type in 904, enter, enter, 901, enter, enter. Now for my closing bearing, what I actually read, or what I actually measure between there, is point to point bearing. Now this one's a little bit tricky because I have a letter in my point IDs. So if I bring up my XYZ box, the syntax of what we need here, because it's got alpha characters in there, I'll just put the letter P at the start, 904A. So if your point IDs have letters in them, you just put the letter P at the start. And then I hit enter, enter. Then my closing point is the same, so I just go 901, enter, enter. So there's my misclose there, probably just over 5 seconds or something. Okay, so in my output, I'll create a new model called Trav1. Copy that into there, and once again I'll make it green, and I can just hit process. Oh, sorry, pick. Shows me my misclose, and then I can hit adjust. So this time, looking at the report, shows me my bearing and distance misclose, and then down here it'll show me my closing azimuth, closing bearing, angular misclose, 6 seconds, number of station setups, 5, and number of the angular misclose per station. So it's put 1 second per station, like I stated before, it's told you what it's done there, 1 second. And also, if we look at the distances, it's kept all of the distances the same as they were originally measured, and just adjusted the angles. Okay, so this method will keep the distances as you read and adjust the angles. Alright, so if I turn that on, just also I'm doing this in version 12. This is also the same for our previous versions as well. Alright, so then I can come in and have a look at my changes that I've made here, which is nice to be able to do that. Now if you don't want this string to be created, like I mentioned before, you can just untick create string and it will just replace your string there, so you don't get double ups of the string there. Okay, so that's our traverse adjustments. Okay, so now we'll move on to least squares adjustments. So I have nothing in my view here. And we go into survey. adjustments, and least squares network. Now in this demonstration I am using the older least squares network. We do have the new one, but due to lack of data at this stage, I'm not using the new least squares adjustment, which is under survey network least squares. We might be able to do one of those in an upcoming webinar. Alright, so the file that I'm going to be using is called an IN file. So if I click onto here, and I've got this one here, least squares adjustment, and then today's date. And if I want to have a look at that file and see what it looks like, we can click on the folder and hit open. So it just opens in a text editor. At the top we've just got a header, we need that. And then it has a number of settings here. Sometimes it's hard to remember what each of these are, but I think this is distances, angles, and a few of the different settings. But to show you how you can see all these, we click on the folder, back into 12D, and click on help here. Now you may say, oh, my help doesn't work. In version 12, we now ship with a PDF help instead of the old CHM file. So hopefully you'll be able to get your help working and finally use all this great information under the help here. So if we come down here, we have the format of the LSA IN file. And basically it's got here the position 1, number of distances, and it's a whole number, an integer, number of angles, number of true azimuth, I'll explain what those are later on, your fixed control stations, number of stations including your control stations, and your standard deviations and parts per millions, so on and so forth. So I'll just keep that open, we might come back to that. So now to read the file, I just hit the read button here, and as promised it's filled out these settings here for us. Now these are the global standard deviations in millimeters that we're happy to achieve, that we're expecting, and also the global parts per million as well. Okay, so if you don't want that in there, you can just delete it out of there. It's whatever you feel. You can also override each distance using the fields in here for every measurement. As you can see, when I click on each one of those, it's showing the distances flicking around the screen there. Now, if I come down, you can see that I have 36 distances there. Alright, then I go on to my angle tab, and I have 35 angles. And you can see here the way this works is I'm set up on station 1, back-sighted to station 5, and foresighted to station 4. And just in the heading here you can see that it's a clockwise angle in degrees, minutes and seconds. So measured clockwise from station 5 around to station 4 was 34, 52, 52. Okay, once again I can also override the standard deviation in seconds for each measurement as well. Down here I've got a scale factor box, and to add initial calculations, maximum number of iterations, so it'll iterate through the data a maximum of 10 times, and it will also stop if it reaches an accuracy of 0.0001. Okay, and then if it starts to increase, it'll also stop as well. I've got that ticked on. So then we'll move on to our true azimuth tab. So in here, if you want to hold an azimuth between 2 marks or between a few marks instead of fixed stations, you can put them in here. Now I don't have that, I have fixed stations. So here they are here, and if we go back to our file, you can see them located in this area here. So station 1, station 2 and station 4. And you can see the number of stations is 3 in there. Alright, so back in the 12D. Then we go to our initial tab. Nothing in there yet. And we'll go into our draw tab, and we'll put in a string name here. I'm just going to use obs. Okay, and then there's just some settings in here. This is the scale factor for the error ellipses. So it's going to, because the errors are going to be so tiny, it's going to blow them out by 1,000 times so you can actually see them on screen there. Alright, so now I can just hit Calc Init down the bottom. And it says Network Initialized. And if I go to my Initial tab, now I can see my initial approximations of my stations. And if I turn on the model, OBS, you can see my network starting to form here. So I have these white stations, and they are my fixed control stations. And I'll just toggle off the string names here. And then the other stations are the initial approximations of these stations to be calculated. Okay, then into my Output tab, I can put in a file name here. So I'll just call it LSA output. So if I need to read this file back in later on, this produces an IN file that I can read back in to add more stations to. So then I'll put in here LSA report. And then the number of decimal places that I want to see. Okay, then I go to my control model, and I'm going to create a control model called, you guessed it, control, and I'll make it green. And I'll put in a line style of station, and then it will create station symbols at those points. Okay, so now I can go to my, once I've done my initial calc, then I can process, and it's adjusted my network. And if I have a look at my report, so you click on the report file, open, and then it goes through your number of control stations, number of unknown stations, observations, so on and so forth. Okay, so then you can have a look through the initial approximations, the current control station coordinates, the distance observations, and then it's got the angle observations, and then your adjusted stations, and it has your SX, SY, SU, and SP. I've also got a document on that which we can put onto the website so you can see what all of those numbers mean. Okay, then you've got the adjusted distance observations, and you can see all of the new distances there as well. Okay, so if I had a scale factor, you would see the difference in the grid here, but because I just had a scale factor of 1, that's my, they should be the same. So then I've got my adjusted angle observations, so these are my new angles, and then the difference here as well, which is good to see. You might have a look at some of these, and might need to go back and adjust them. Then I have my reference variance in here. Once again, in the document, you can have a look at this here, but basically anything under 1 is a good result. Once it starts pushing above 1, you're starting to get errors. Now, it could be that your original estimate of what you think you can achieve, you might be overestimating that, so if you put a higher number in your standard deviation, it might bring this reference variance down. Okay, so back in the 12D model, if I go to my control model now, I can hit update here. So this will create my control stations. So I just hit update, and down the bottom here, 7 stations created, 0 stations updated. So if I ran this again at a later date, it would say 7 stations updated, 0 stations created, and 7 stations updated. Unless I add more marks in, then it will reflect those numbers as well. So now that I've done that, now that I've adjusted it, I also see these error ellipses here. So I can see in which direction the adjustment has pulled it in here. And if I toggle on my string names, it shows you your U and V values in here of how far it's pulled it. And you can see this one's by 0.7 and 0.4. And if you have a look at the different ones, you'll see the direction that they're pulled in. And you can see the ellipse that it's put in there. Okay, so it's nice to be able to see these. If you end up with big error ellipses all over the place, you know that you've done something wrong and you may need to go back and check some of your measurements. Okay, and then if I turn that off and turn on my control model, there's my adjusted control network ready to use. So that's it for the adjustments for today. If you have any questions, as Lisa mentioned, please type them in as shown in, now I'll bring it back up, the PowerPoint, into your message box there if you have any questions.
Thanks, Paul. I won't read out any of the questions live today. We're just sort of running a bit close to time, so we might just get back to everyone by email for those there. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our next two training webinars are Creating Custom Outputs and Reports in 12D Drainage on the 10th of November and 12D Field Pickup on the 16th of November. We've also got another couple of industry solutions webinars we'll slot in before the end of 2016, so do see our website for details of all of those. We'll keep updating it with many more topics in coming weeks and also continue to keep you posted through email and social media. If you need to contact us in the meantime, our details will pop up on the screen shortly. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.